Yes.
All right, perfect. So let's start the session. So guys, today we are here to see the introduction to big data and Hadoop. Let's quickly see the agenda for the day. So today we are going to see what exactly is the big data. We are going to see different aspects of big data. Then after that we'll see what were the conventional approaches and problems associated with those conventional approaches. That's why big data technologies came into the picture. Then we are going to discuss the solution of the problem called big data, that is Hadoop. What is Hadoop? Then we are going to discuss two components of Hadoop, that is HDFS and MapReduce. After that we'll discuss Hadoop use cases, the real life use cases of Hadoop, and number of companies who have implemented Hadoop and how exactly their conventional approaches and Hadoop approach is different. Then we'll see the complete Hadoop ecosystem. At last we are going to see, we are going to have your questions. So guys, for today's session, I'm going to take your questions at the end. In the actual sessions, you can ask at any point of time. All right, let's quickly understand the big data. So guys, I have taken 4 different definitions of big data. The first two are for you to understand. These are little small one, little basic one, and next two are from the big players, big giants. So guys, the very basic definition about big data is, big data is all about finding the needle of values in haystack of structured, semi-structured and unstructured information. So guys, if you are having huge volumes of data, if you are having the data available with you, the reason why big data technologies are coming into the picture, because we want to find out the information, we want to find out the insights, we want to find out the reports out of these information about from this data. And your data can be in a number of different format. The very first format, structured data. All of us understand structured data, right? The data that is in the form of rows and columns. The data that is in the form of rows and columns that can be stored in RDBMS easily. That's called structured data. The second type of data is semi-structured data. Semi-structured data, guys, simple example, XML or Excel. These can be considered as semi-structured data. So guys, the semi-structured data can easily be converted into structured format via pre-processing. Now, the third format of the data is unstructured data. Unstructured data like the paragraph in front of your screen, like social media data, like images, videos. So guys, this unstructured data is the huge, and we don't have any mechanism from the, if I talk about the conventional methodologies, we don't have any mechanism to handle unstructured data. Alright, we'll discuss about unstructured data in a little more detail later. Now another definition, guys, big data is extremely large data sets. A big data is extremely large data sets that are hard to deal with. Using relational databases. Guys, till around 2005, relational databases were fulfilling the industry's requirement, and everybody was pretty much happy with the relational databases. But after that, when the volume started increasing, after that when the variety started increasing, then people started facing lots of issues with the relational databases, and that is where big data technologies came into the picture. Now with the last 10 years, people are now seeing huge volumes from a number of sources. Like social media is the biggest source of data. Apart from that, if we talk about, say, any industry specific, say telecom industry, they are getting the data from user review websites, user feedback, from sensors, from network elements, from n number of sources. Surely the conventional sources are surely included like UDRs, CDRs and all. The volume of this data is increased like anything. Guys, if I give you a very simple example, so if I recall my college days, at the time I was having the computer whose hard disk was merely in MBs, merely in MBs. Now today all of us are getting the subsystems laptops which is having the RAM hard disk of at least 1 TB. The servers are having terabytes of hard disk. 50 terabytes is a rough approximate size of each and every server. Why? Because our requirement, even for a common man, the requirement of the data has increased like anything. Another small point, data that exceeds the processing capacity of conventional database system can also be considered as a big data. Guys, we are looking at the very big buzzword, big data. Before going to Hadoop, I want you to take through the big data. What exactly is the big data? Because today everybody is talking about big data and big data. Now, if we see all the dimensions of big data, Gartner defines big data as high volume, velocity, and variety information assets. It's not just about volume. With the volume, we are having the velocity. By the way, guys, in next slides only, we are going to discuss about velocity and variety. So big data is not only about volume but also about velocity as well as variety. So guys, these information assets demand cost-effective, innovative form of information processing for enhanced insights and decision making. Guys, why everybody is running behind big data? Just to help the business in better decision making, just to get better enhanced insights from the data. Like if I give you a few examples, prior to 2005, people's business requirement was like historical requirements, like what was my sales last year, last 6 months, or last festive season. But today the requirements has been changed to what will be my sales, what will be my sales next year, what will be my sales next say 6 months, so that business can make the prior decision. Guys, I'm sure you are aware of the e-commerce websites, like say take the example of Flipkart or Amazon. There if you see that there is a section products you may like or recommended products. These all are nothing but the examples of big data. With the help of machine learning, with the help of Hadoop, these such type of recommendations are possible. With the help of these recommendations, with the help of these big data applications, business is getting improved. Business is getting more and more profit. Now, guys, another thing why it needs another innovative form of information processing. The reason is IBM has told that today more than 80% of the data captured is unstructured. Today, if we see, more than 80% of the data is unstructured. Now guys, if you recall, our legacy systems, our conventional systems, our DBMS can't handle unstructured data. They can't handle unstructured data. So that's why we need an innovative, a new solution to handle these unstructured data. So guys, we are getting the unstructured data from sensors, which is used to gather the climate information, post to social media sites, digital pictures and videos, purchase transaction records, cell phones, GPS signals, and so on. All of these unstructured data is also big data. So guys, if you recall, so if I take another example, say sensors. If you recall a few years ago, we were not able to identify. We were not able to identify that whether anything, any natural calamity is about to come. Will there any issue? Will there any natural calamity like earthquake or cyclone is will be coming? But today, with the help of big data, let's take the recent example, Hudhud. The cyclone Hudhud attacked Visakhapatnam. The government already knew that Hudhud is going to attack Visakhapatnam at this particular place. Government already knew that it will attack at this particular time. So they took preventive action. They took preventive action. Guys, this is the best example of big data, that before the cyclone is hitting us, we came to know, okay, this type of things is coming and we can take the preventive measures. Alright, let's move ahead. So guys, that's a very basic definitions about the big data that I have given. Now let's see another examples, few big sources of big data. So guys, till now I have given you, say, okay, we are getting these type of data, these are the definition, and we want to do this with the data. Now if we understand the volumes, huge volume that is getting generated. So guys, daily every second we send 2.9 million emails every second. If I give you another example, every minute 20 hours of videos are uploaded on YouTube. Let's take another example. Google processed 24 petabytes of data. That's huge. 24 petabytes of data per day. There is 50 million tweets per day. Total time spent on the Facebook, total minutes spent on the Facebook each month is 700 billions. So guys, just giving you a glimpse of, okay, the volume that of the data that is getting generated. Now you understand it easily that yeah, these are the sources, and these are type of volume of data is getting generated. Let me give you a few examples from the industry. If I give you the example of Walmart, guys, Walmart is having 200 million weekly customers. 200 million weekly customers across 10,700 stores in 27 countries. Now you can imagine the volume of data they are having. They are having 1.5 million customer transactions every hour. So guys, so far they have collected 3 petabytes of data. So far they have collected 3 petabytes of data in their Hadoop cluster. Guys, by analyzing this data set only, they are running a number of campaigns, promotions and all. Say for example, they are having, as we have seen, there is millions of customers are there. Just imagine, even they are having millions of customers, then also they are able to provide a specific advertisement to a specific customer. Say for example, if I am visiting Walmart, the offer for me is different. The offer for me is different. Offer that they are showing me is different. Offer for you is different. They have processed the data user-wise. They have processed the data, and based on that they are sending the recommendation, they are sending the promotions, advertisements and all. Okay, regarding this we'll discuss more in use case section. What are the different type of use cases of big data? Let's see another example of big data. Facebook. All of the people today are using Facebook, social media, social networking site. Now guys, there are 4.5 billion Facebook likes every day. 350 million photos are uploaded on Facebook daily basis. Now you can imagine the volume that Facebook is having. Facebook is having 250 billion photos stored. Apart from that, guys, we send 10 billion messages using Facebook every day. every day, guys. That's huge. Now, there is 1 trillion posts in Facebook's graph search. Facebook processes 500 TB of data daily. By the way, guys, this huge volume of data Facebook is handling with the help of big data technologies. They are handling the same with the help of Hadoop. By the way, guys, if you are using the chatting or messaging of Facebook, it's developed on the top of Hadoop and HBase. The photos, if you see profile pictures of each and every user is stored on HBase, a NoSQL database. Guys, if you have noticed that when you open the Facebook, the photos shared by your friends are getting loaded little slow as compared to their profile pics, because all the profile pictures in the Facebook has been stored in HBase, the NoSQL database. Alright, so guys, that's an example of big data generation. Let me quickly give you the big picture of big data. That is the complete picture of big data. That is the 4 V's of big data. Now guys, try to relate these 4 V's, these examples with your own work experience. Now, firstly, let's talk about the volume. Volume means data at rest. Volume is the data that has been generated and is reached to my data center. Now guys, it is estimated that we generate 2.5 quintillion bytes of data daily. World create 2.5 quintillion bytes of data daily. 2.5 quintillion means 2.3 trillion gigabytes. 2.3 trillion gigabytes. Another thing, by 2020 there will be 40 zettabytes or 43 trillion GB data will be there on the earth. So guys, if we are having huge volumes of data, we understand that these volumes are not handled by RDBMS. We know that, say for example, if my volume increase beyond a certain limit, if I take the example of Oracle, since it is deployed on single machine, it can handle data up to a certain limit. If we store more than that, it is going to break down. Now that is the very first very easy dimension, very easy essence for big data. Let's talk about the next one, that is velocity. It's very important. It's very important dimension of the big data, velocity. Guys, velocity means the speed at which the data is generated is equals to the speed at which the data should be processed. My processing speed should be as fast as the generation speed of the data. Let me give you an example. The New York Exchange generates 1 terabytes of trade information during each trading session. That's huge. Another example, guys, regarding the velocity, if I give you. So guys, today millions of people are using credit cards. Now just imagine if you are using credit card, when you supply the password, after that it is taking merely few seconds to authenticate you. Now just imagine, say for example, I want to find out, say for example, I am the part of the credit card company, I am the part of the bank. I want to analyze whether the transactions are fraudulent or not. Understand it carefully, guys. Say for example, let me give the example of fraudulent. Okay, at 9 a.m. if anybody is doing the transaction from Mumbai, at 9 a.m. if anybody is doing the transaction from Mumbai, and just after 2 minutes if a transaction request, say from Chennai, it means there is something fishy, something wrong. This transaction should be stopped. Usually the card holder was doing the transaction from transaction in, say, another currency. Now it is in some different currency. This transaction should be stopped. Guys, now to identify the fraud, just imagine the data is traveling. Millions of users are using the credit card, so millions of streams, the data is traveling from the client machine to the transaction systems. Transaction systems, once they authenticate, this data will go to the analytics system. Now in the analytics system, this data will be analyzed. This data will be analyzed for the different fraud patterns. Now guys, the interesting fact is that the analytics system is having just few milliseconds to analyze this data. So the velocity of the data is very high, and to process this data, they can't wait that till the data is stored. We need to do data in motion analytics. Guys, a very new term in the industry, data in motion analytics we need to do. That is, while data is traveling, while stream of data is coming, I'll process that data in real time without any delay. Without any delay, I need to process this data. Now, so guys, that's all about the velocity. Now let's talk about the variety. So guys, as we understand, as broadly if I classify, there are three varieties of big data. There are three varieties of, even I should say, data. The very first variety is structured data. Structured data, we have already discussed that. Second, semi-structured data, and third is unstructured data. Now, if we go a little deeper inside this, so guys, if I talk about, say, healthcare industry, so as of 2011, the global size of the data in just healthcare is 150 exabytes. 150 exabytes. Guys, just imagine 150 exabytes or 161 billion gigabytes. This much huge volume of data, this much huge volume of data is already there. If I give you another example, there is 30 billion piece of content are shared on Facebook every month. 30 billion, guys, 30 billion is a very, very big figure. 30 billion posts, or say overall including images and media. 30 million pieces are getting shared on the Facebook. 400 million tweets are sent per day by about 200 million monthly active users. So guys, that is about different varieties, different types of data. If I give you guys, 4 billion hours of videos are watched on Facebook, watched on YouTube each month. Each month, 4 billion hours of videos. I can imagine the volume. Imagine the variety and number of different varieties of data is getting generated. Now, let's move to another dimension, guys. It's although a minor dimension, that's the veracity. It's although a minor dimension, but a very important and tricky dimension. What, guys? Veracity means uncertainty in the data. Veracity means uncertainty in the data. It means the data that is I am collecting may have noise. The data I am collecting may have noise. The data may have ambiguities. Data may have some extra information. Guys, the data that is collected today is having lots of noise, and we need to remove that. The data collected today in practical scenario is called dirty data. The data that we are getting is not clean. So guys, the data needs to be clean. In the practical, in actual industry, we usually clean this dirty data with the help of pre-processing. We usually do a number of pre-processings to clean the data, to clean the dirty data. Okay, so let's move ahead, guys. That's about the 4 V's of big data, out of which 3 V's are pretty important, pretty crucial. The fourth V, although minor, but tricky. And even fourth one, the veracity, is very important, because today guys, the data on which I'm taking the decision, if I'm not confident, the decision on the decision also I will not be confident, and there are chances that my decision won't be correct. Now guys, let's see the conventional approaches. Conventional approaches, RDBMS, which was there in the market for quite long. RDBMS was there in the market for early 80s till mid 2005. Till 2005 they were able to fulfill our requirements. Guys, we were using, in terms of conventional approaches, the most popular is the RDBMS for the structured data. RDBMS means Oracle, DB2, MySQL, MS SQL, etc. Guys, usually people are storing all their data into RDBMS. After, if the data is semi-structured or unstructured, if possible the data is pre-processed, then converted into structured form and loaded into RDBMS. For unstructured data, industry is using OS file system. Now for the pre-processing in RDBMS we use SQL queries, and for unstructured data, so at many places the most popular choice is C++ or Perl Python. For the processing, for the parsing, Perl is the best solution. Now understand one thing carefully guys, today these conventional approaches are not fulfilling the requirements. They are not able to answer the questions what I am asking. Today they can't handle the volumes, they can't handle the variety, they can't handle the velocity of the data. They can't answer my question, they can't answer my business question about predictive analytics, like what will happen or this user might like. But these conventional approaches were very good for the small volumes of data, for the structured data, or if I say till 2005 these technologies were very good. But with the big data we are facing a number of different solutions with these conventional approaches. What are the problems? Let's discuss one by one. So guys, the very first problem is limited storage capacity. Limited storage capacity. I can't store the data beyond some value, beyond some volume. So guys, since these conventional approaches are deployed on the single machine, we can't store the data beyond a certain limit. If I share an example, when I was working with a leading telecom operator here in India, they are having the issue of volumes. They are having the issue due to which they need to archive the data again and again. They need to archive their old data again and again. Guys, archival of the data is always a big pain point. Archival of the data is always a big pain point. Why? Because guys, if you are archiving your data, you need to archive the on the tape, and loading the data back will take huge time. If I take the example of the telecom operator, they are again and again getting the requirement from the business to process the old data, to generate the insights from the old data. So again and again they need to load the old data back from the tapes. Now, by the way guys, regarding use cases, we are going to discuss in use case section in great details. Now let's discuss about limited processing capacity. Limited processing capacity guys, since they are deployed on the single machine, since these conventional approaches are deployed on the single machine, we are having the limited number of CPUs, we are having the limited number of CPU cores. To process the data, to process huge volumes of data, it takes really long time. Few well-known issues: no scalability, we can't add more machines, we can't add more resources on the fly, we can't add more resources without any downtime. Even addition of the more nodes or horizontal scalability is not feasible in the conventional approaches. Guys, just after this we are going to discuss big data approach. So when we are going to see the big data approach, at that time just from the design principle, just from the architecture, just from the basic architecture, we'll come to know that big data is solving all the problems from just basic architecture. Single point of failure. Another issue with the conventional approaches is the single point of failure. If your machine goes down, you don't have any hot standby, you don't have any hot backup that will automatically take over. You need to wait until unless that machine becomes up. Sequential processing, since it is deployed on single machine, we can't have true parallel processing. We can't have true parallel processing. RDBMS can handle only structured data. RDBMS can handle only structured data. What about the unstructured data? As we know, more than 80% of the data generated today is unstructured. RDBMS can't handle unstructured data. But guys, another big issue with these conventional approaches is that they require pre-processing of the data. RDBMS use ETL methods which requires pre-processing of the data before loading. Guys, a golden rule of big data industries from the data scientists: data is in its richest format if it is in raw format. Alright. So guys, if we compare, before entering into the big data approach, if we compare both the approaches, that is traditional approach and big data approach. In the traditional approach, it is about structured and repeatable analysis. Here, business user determine what question to ask, and IT structures the data to answer the question, like monthly sales report, profitability analysis, customer surveys, and so on. On the other hand, if I talk about the big data approach, it's iterative and exploratory. Here, IT delivers a platform to enable creative discoveries, and business explores what questions could be asked, like brand sentiments, like product strategy, like maximum asset utilizations, etc. Now guys, after understanding the big data, the 4 V's of big data, all the dimensions of big data in great details, after understanding the conventional approaches and problems with the conventional approaches, let's enter into the world of big data. The solution of all the problems that we have discussed is Hadoop. The answer for all the problems is Hadoop. So guys, big data is the name of a problem. Big data means I am having huge volume, very high velocity, high variety of the information assets, and Hadoop is the solution that can handle all such type of data. Let's quickly start about Hadoop. So guys, what exactly is Hadoop? Hadoop is an open source project from Apache Software Foundation. So guys, basically Hadoop is open source from Apache. It is developed at Apache, but Hadoop is getting sold by the big players like IBM, like EMC, Pivotal, like MapR, like Cloudera. So guys, if you take up Hadoop from Apache, you don't need to pay any license fee. Even Cloudera is also providing it free of cost. Hortonworks from Yahoo, they are also providing it as an open source only. Hadoop provides a software framework for distributing and running applications on cluster of servers. Cluster of servers, guys, understand this line carefully. Cluster of servers means multiple machines connected together. Multiple machines connected together. It means Hadoop doesn't work on single machine. It works on multiple machines, hundreds or even thousands of machines. Now guys, another important point, it provides a software framework for distributing and running. It distributes the data over the cluster and it runs the applications over the cluster. We are going to understand this particular definition in great detail in next few slides. Now guys, Hadoop is inspired by Google's MapReduce programming model as well as Google file system. As we know, Google is the mother of all the invention. when Duck Cutting and his team was working on the Nudge search engine at Apache, they got a requirement which was pretty much similar what Google has already developed. So Google has written a white paper, and Duck Cutting and his team at Apache started referring that white paper to create a sub-project of Nudge, but due to power and popularity of Hadoop, soon Hadoop became the top level project. Guys, Hadoop is open source framework that is written in Java. By the way, guys, Hadoop is that much popular. Hadoop is that much demand in the demand. Why? Because of its architecture, because of its innovative architecture. Hadoop is developed by the top-notch talent in the industry. The more than 90% of the code came from companies like Facebook, Yahoo, Cloudera, IBM. That's why Hadoop is a very innovative solution of the big data problem. Now, if you see that, guys, Hadoop is written in Java, but it doesn't mean that we can code only in Java. Hadoop provides us a mechanism with the help of which we can code in C, C++, Perl, Python, Ruby, Groovy also. And number of even all the languages we can code. And even if anybody is from the SQL background, they don't know the programming, you don't need to lose heart. Hadoop provides a mechanism with the help of which you can just type SQL query and that query will be converted into code. Alright. So guys, Hadoop efficiently processes large volume of data on a cluster of commodity hardware. Commodity hardware means low-end hardware which we use for our day-to-day purpose. Commodity hardware which we use for our day-to-day purpose. Guys, it efficiently processes large volume of data. Hadoop is developed to process large volume of data, not the small data. Make a note of this point that if you are having say few MBs of data, don't go for Hadoop. If you are having merely few GB of data, don't go for Hadoop. If you are having huge volume, even if not huge volume, if a moderate volume with a huge velocity, or if moderate volume, moderate velocity with huge variety, you should go for Hadoop. Now, guys, till now again and again I was saying that Hadoop can be deployed on cluster. Till now again and again I was told that we need to deploy Hadoop on cluster. Cluster means multiple machines connected together. Now you'll ask me, I don't have any cluster, what will I do? So guys, don't worry, Hadoop can be deployed on single machine. Hadoop can be deployed on single machine for your testing, for your R&D, for your learning. You can deploy on Hadoop on single machine. But for the production, to get the real power of Hadoop, we need cluster of machines. Now guys, another important point is that Hadoop can be scaled. Hadoop can be scaled from single machine. Hadoop can be scaled from single node to thousands of the node on the fly. Guys, this on the fly is very important, very big word. It's really very big word. I will discuss on the fly. This will take around half an hour in actual sessions. Alright, let's see two components of Hadoop. Hadoop is having two key parts. One is the storage layer. The storage layer, that is Hadoop distributed file system. Storage layer, that is Hadoop distributed file system. Guys, Hadoop distributed file system is the file system to handle the data and map reduce. The second layer, that is the processing layer. The map reduce, the processing layer, which is the heart of Hadoop. Hadoop is that much popular, Hadoop is that much demanding just due to map reduce. Guys, Hadoop is that much fast just because of map reduce. So the processing layer is the map reduce. Now, before entering into these two components, let's firstly see the basic architecture. Let's firstly see the basic architecture of Hadoop. The guys, if you see this architecture, Hadoop is having two different type of nodes. The very first type is the master and second is the slaves. The very first type is the master and second is the slaves. So guys, Hadoop works in master and slave fashion. Hadoop works in master and slave fashion. Guys, as the name is suggesting, master doesn't do any work. Master doesn't do any work. In fact, it takes the works from the slaves. Hadoop take the work, master takes the work from the slave. Master's work will be for the coordination and assignment of the work. For the management, master is used. So for example, if a user is submitting any work, if a user is submitting any work, master will submit same work to all the slaves. Guys, understand this carefully. Till now, with conventional approaches, we had just single machine. Like user will submit his requirement, his algorithm, his code, his processing, his SQL query on Oracle machine, and that single machine will process and return the answer. Now with Hadoop, it's not merely a single machine. Suppose I am having a 100 node cluster. Suppose I am having 100 slaves there in one master. When user submit the work, when user submit the job, when user submit any processing or data crunching job on the master instance send the same work to all the slaves. Guys, all the slaves will be working in parallel to process the data, to perform the work. Guys, understand it carefully. Suppose I am having a 100 node cluster. Suppose there are 100 slaves in the cluster. Now the work done by each machine will be almost 100. Just 100th work will be done by each and every machine. In this manner, my job will be 100 times faster. The job will be 100 times faster. And even I can add more machines. Today I am having 100 slaves. Tomorrow if requirement increase, I can add more machines. Tomorrow if requirement increase more, I can add more and more machines. Suppose add 50 more machine, it will be 150 cluster. Add 100 more machine, it will be 250 node cluster, and so on. More and more machine you are adding, that will add storage as well as computing power in the cluster. Okay, so guys, let's move ahead to the HDFS. HDFS, Hadoop distributed file system. Guys, Hadoop distributed file system, as discussed, this is the storage layer of Hadoop. Hadoop distributed file system is designed to run on commodity hardware. HDFS is highly fault tolerant, distributed, reliable, and scalable file system. Guys, what are all these terms and what do I mean by these terms? We'll see in actual sessions, because it needs much more description. But few of this, like fault tolerant and distributed, we'll see in just next slide with some animation that will make it quite easy. HDFS provides high throughput access to application data. HDFS provides high throughput access to application data. What do I mean by that, guys? Since Hadoop is distributed, since it is deployed on multiple machines, we can read the data, we can get the data at very high throughput. HDFS is developed to handle huge volumes of data. It is used to handle large files, the file of size GBs to TBs. Now guys, last 2 points are very important. How exactly Hadoop stores the data? The storage mechanism of HDFS. A file is split up into blocks. And stored distributedly across multiple machines. A file is split up into blocks and stored distributedly across multiple machines. HDFS stores multiple copies of the data on different nodes. Now guys, understand it carefully. This is the most important point. Let's understand the same thing via some animation. Suppose I am having, on the left hand side you can see I am having a very big file, a large file whose size is 100 terabytes. Now I am having a cluster, what we have already seen, a master and a slave. There are a master and hundreds of slaves. Now if I want to store this file, in HDFS, firstly the file will be splitted. Into small blocks. Look at this: block 1, block 2, block 3, block 4, and so on. Guys, the default block size is 64 MB. The default block size is merely 64 MB. Now you can imagine how many blocks will be created. It will be 100 into 1000 into 1000 upon 64. That many blocks will be created. Thousands of blocks will be created for this particular file. Now guys, these blocks will be stored distributedly. Look at this animation. These blocks will be stored distributedly. Like block 1 came to here, block 2 came to here and stored here, block 3 is stored here, block 4 is stored here. Guys, all these blocks are stored distributedly. For the simplicity of the figure, I'm just showing you with the 4 blocks. I'm just showing this example with the 4 blocks. Now you can see there will be thousands of the blocks for this large file, and that is stored distributedly across all these slaves in the cluster. Block 1, block 2, block 3, block 4, block 5, block 6, block 7, block 8, block 9, and so on. Now that is the main innovative way of storage. Now another key point here is that just not it is distributedly stored, it also creates multiple copies of the data. HDFS creates multiple copies of the data. Look at this. Block B1 is stored here as well as here as well as here. Block B2 is stored here as well as here as well as here. Block B3 is stored here, here, and here. Guys, by default HDFS creates 3 replicas or 3 copies of the data. Each and every block is available at 3 different nodes by default, although you can increase or decrease these particular replication factor. Now, what is the requirement of replication factor? Understand this carefully. As I told you, we can have hundreds or thousands of the nodes in the cluster. Suppose I am having 100 slaves. But out of which, suppose this slave goes down. Suppose at any point of time this slave fails. There was a hard disk issue, or there was a power failure, or there was some extra issue, some XYZ issue in this particular machine. The failure of this machine should cause the failure of the complete cluster? No. The question is, if just single machine fails, so will my complete cluster of no use? The answer is it should be usable. That's why Hadoop creates multiple copies of the data. If this particular node goes down, no issues, block 1 will be accessed from here or here. Since we are having multiple copies of the data, it can be accessed from any location. If a machine goes down, then also my data will be stored reliably. This particular property is called fault tolerance. If you recall, guys, in the HDFS slide we have shown you that HDFS is fault tolerant. So guys, this is the way HDFS is fault tolerant. Okay, so guys, that's a very basic about HDFS. That's about how exactly HDFS stores the data, how it creates the replicas, about all these different things. What should be my block size? 64 MB is default. Can I increase? Can I decrease? Where exactly the blocks are placed? What is the placement policies? What are a number of different properties like reliability, like fault tolerance, like high availability? We are going to discuss the same things in great detail in actual sessions. Alright, so guys, the next topic is MapReduce. MapReduce. What is MapReduce? MapReduce is the programming model. MapReduce is the programming model for processing large volumes of data. MapReduce is designed to process large volumes of data in parallel. You guys understand it? It's processing large volumes of data in parallel by dividing the work into set of independent tasks. By dividing the work into set of independent tasks. My work, as shown in the previous figure, guys, work will be divided into small tasks, and which will be done on each and every slaves in parallel. Let's see another definition of Hadoop. MapReduce. MapReduce is the heart of Hadoop. MapReduce is the heart of Hadoop. It moves computation close to the data. Instead of moving data to computation, it moves computation close to the data. This programming paradigm allows for massive scalability. This programming paradigm allows for massive scalability across hundreds or thousands of servers in a Hadoop cluster. Let's understand the same via some animation. So guys, again, left hand side you are having a user, and right hand side we are having a Hadoop cluster where we are having already the blocks are stored, like block B1 here, B2 here, B3 here, B4 here. Now guys, understand it carefully. When user previously came, he stored the data. He stored the data into Hadoop cluster. User stored the data into the Hadoop cluster. How exactly the data was stored? Data was stored pretty much distributedly. Data was stored distributedly. Like blocks are created and few blocks are stored here, few blocks are some other machine. Now again the user will come, user will interact with the master and will say, boss, the file that I have given, for user it is a file, for user it is just a single file. User will tell that, boss, I have submitted you file, I want to process that file. Now for the same, user need to write an algorithm, an application that is called MapReduce application. Now guys, understand it carefully. User needs to write MapReduce application. User needs to write MapReduce application to process the data. So to process the data, he has developed a MapReduce application. User will submit this application over the master. Look at this. The application has been submitted to the master. The application has been submitted to the master, but master doesn't do any work. Master doesn't do any work. Instead of that, master sends the same algorithm. Master sends the same algorithm to all the slaves wherever the data is available. Wherever the data is available. Look at this. One copy of the algorithm came here, which will process block 1. One copy of algorithm came to this slave, which will process block 2. Another copy of algorithm came here, which will process block 3, and so on. Guys, this is a very innovative way. This is a very innovative way of processing. This is a very innovative way of handling the data. Because instead of moving the data to algorithm, we are moving algorithm close to the data. We are moving algorithm close to the data. Now guys, that is the most important principle MapReduce is having. That's called data locality. That says that instead of moving the data, move algorithm close to the data. Alright, so guys, that's about the basic about HDFS and MapReduce. Now let's jump to the use case section. Guys, the very first use case, credit card fraud detection. We have already seen this use case. We have already discussed about the credit card fraud detection. Now let's jump to the next use case, sentiment analysis. Sentiment analysis is a very important use case. So guys, before explaining, let me give you one example or a use case. When I was working with one of my client, we got a requirement. What was actually the requirement is, we got the requirement from the client that they want to know whether the people the customer are liking their products or not. Whether the customers are liking their products or not, they want to know as soon as possible. Say for example, today they are launching the product and tomorrow or even as soon as possible, like today or within a week, if they can come to know whether people are liking the product or not. Like guys, in actual conventional scenario, what happens? If today a company is launching a product, after almost 6 to 8 months they comes to know whether the product was successful or not based on the sales data. Based on the sales data, they come to know, okay, whether that product is successful or not. But in this 6 to 8 months, there was a n number of hundreds of thousands of units were manufactured. Hundreds to thousands of units were manufactured, and the product was a big failure. There was big blunder in the product. There was a big loss that is going to happen to the company. So guys, the requirement was if we can provide this particular feedback as soon as possible. This is one of the leading product developer in US. So guys, we know in the US people are pretty much active on the social media. So we use the same. We try to find out the sentiment of the user. What exactly people are thinking about the product. What people are thinking about the product. Now let me explain with this particular slide what is exactly the sentiment. Now guys, sentiment analysis provides the substance behind the social data. It processes the language and text to identify and understand consumer feeling, his attitude towards brands or topic or any other discussion. Now, if a company is launching a product, using sentiment analysis, we can identify users' opinion, whether people are liking it or not, whether people are liking this particular product or not. If yes, they like it, what exactly they like. If not, what they don't like. Say for example, a specific property, a specific feature of the application, a specific application of the specific, say for example, a specific feature of the application user is not liking, then based on users' opinion, product can be improved. Based on users' opinion, product can be improved. Guys, it enables business to make early decision. It makes business to take early decisions, like in a day or within a week only, rather than waiting for sales report, which might take 6 to 9 months. We can easily find out users' opinion, whether they are liking about it or not, whether they are liking the product or not. If they are liking, what exactly they like about the product. If not, what they don't like. Guys, this is a very nice application. Frankly speaking, guys, this particular application today is getting implemented at every consumer facing industry, as every customer facing industry. What people are liking about them, what they don't like about them, and so on. This type of questions are getting solved with this. Alright, so guys, that's about the sentiment analysis. Quite big application. Now guys, let me share you few more applications. So guys, when I was working with a retail client, my client is getting 100 GB of invoice data daily in XML format. My client is getting 100 GB of XML data daily. Now, the requirement is that this XML data or this invoices needs to be converted. These invoices needs to be converted into structured data, but this conversion involves complex business rules, very complex business rules, complex validation and verification. Guys, these business rules were that much complex that the time requires via their conventional approach. They had already their conventional approach in C and Perl. The time required to process the data was 10 hours. time required to process the data was 10 hours since the business rules were much too complex. Guys, when I visited them, I got a request if I can reduce this 10-hour time to 5 hours. If via any mechanism this particular time can be reduced from 10 hours to 5 hours, when we develop the solution in big data, we use big data approach, we develop the solution in MapReduce, that is in Hadoop. Guys, you'll say wow after looking at the result. Time taken to process the data was merely 10 minutes on a cluster of 10 nodes. That was a very big achievement, frankly speaking, guys. Although it was a small project, but we got n number of different appreciations from the client. We got 3 more account open from their sister companies just due to this particular application, just due to this, the power. When we shown the power of big data, we reduce the processing time from 10 hours to 10 minutes. It's a rough. It was approximately 10 hours, means sometimes it's 9 hours 15 minutes, sometimes 10 hours 10 minutes. So it's approximately 10 hours 9 minutes or in few seconds, or 10 minutes few seconds, like that. But guys, it's a very big achievement. That's the beauty of big data. Now let me show you another application, another use case from Sears Holding. So guys, Sears Holding, a big retailer, they are using Hadoop to personalize their marketing and loyalty campaigns. Sears is having 4,000 stores and millions of product. They are having 100 million customers. Now guys, Sears has collected 2 petabytes of data so far. The problem that Sears is facing is their legacy system is incapable of analyzing large amount of data for personalizing marketing and loyalty campaigns. Now guys, do you know that usually all these campaigns, all these loyalty campaigns, all these advertisements, all these marketings are personalized. Like for a specific user, offer is different. For a specific another user, a specific offer will be provided to him. Say for example, if I'm liking mobile phone, they will provide me a specific offer in mobile phone. If you are liking say laptop, they will provide you an offer in laptop. So via doing the advanced analytics, they will come to what exactly you like. Apart from that, say they will analyze your buying and searching pattern also. Say for example, you daily purchase butter and bread. You daily purchase butter and bread. What is the probability that you will purchase milk also? If the probability is high, they will provide you offer in the milk. Now guys, conventional approach, they were able to analyze just 10% of customers data. They were able to analyze just 10% of customers data for personalizing loyalty campaigns on mainframes, Teradata and SAS. The processing time to analyze the data, just 10% of the data. The processing time to analyze just 10% of the data was 6 weeks. That's huge. Now guys, just imagine I need another 1.5 months to process just 10% of the data. What about the data that has been captured in this last 6 weeks? And what about the rest 90% of the data? They have shifted to big data approach. They shifted to Hadoop. They shifted to Hadoop with 300 nodes. 300 nodes, merely commodity servers. Now guys, look at the magic. Time taken to process the data was 10%, for 100% of the data. This time with the big data, they were able to process 100% of the data in nearly 1 week. Now guys, look at this, 10% in 6 weeks, 100% in merely 1 week. That's the beauty of big data. By the way guys, these all the figures whatever I'm showing to you, these are available publicly. They are available on the Google also. You can go through the Sears use case over the Google. It's a nice case studies available. Another thing, interactive reports can be developed in 3 days. Interactive reports can be developed in 3 days instead of 6 to 12 weeks. Now guys, look at again the performance, look at the magic. So guys, they saved millions of dollars in mainframe and RDBMS cost. And since Hadoop is open source, free, and they don't need any specialized hardware, they were using commodity hardware. So guys, they saved millions of dollars in this, and they got 5,000% better performance. That's huge. 5,000% better performance. Now that's far beyond the expectation. Now guys, they increase the revenues through better analysis of customers' data. Through better analysis of customers' data, they increased their revenues like anything. So guys, that's it about the use cases. Now let's quickly see the Hadoop ecosystem. So guys, in the Hadoop ecosystem, if you see, we are having HDFS. HDFS is the lower layer. HDFS is the lower layer. That is storage layer, which we have already seen. MapReduce is the processing layer. MapReduce is the processing layer. Apart from that guys, there are top level components like Hive and Pig. As I told you, for MapReduce we need a programming knowledge. But if person don't know programming knowledge, no issues. He can use Hive if he is from SQL background. User can write SQL queries in Hive, and Hive will convert that into MapReduce program. User can write scripts. User can write simple scripts in Pig, and Pig will convert that into MapReduce job. Now guys, apart from scripters, apart from developers, apart from admins, apart from analysts, there is a mechanism, there is a place for the ETL lovers also, the persons who are from ETL background. For the ETL we have Scoop and Flume. Scoop and Flume is for the ETL. For the ETL we have also Uzi, that is a workflow manager. Now for the database, but by the way, this is not a SQL database. This is a NoSQL database, that is HBase. HBase is also the part of the Hadoop family. That is a NoSQL database. NoSQL database, that is a part of Hadoop family. Guys, that is about Hadoop ecosystem. Although I took it a little quickly, with our course we are going to handle the complete ecosystem also. Now guys, let's quickly see the future of Hadoop. Guys, according to IDC, big data market revenue will grow at 31.7% a year, and it is going to reach 23 billion mark, $23 billion mark in 2016. Another IDC forecast that big data market is growing at 27% compound annual rate, and it will reach 32.4 billion through 2017, which is 600% the growth rate of overall IT market. Guys, now you can see, this is from IDC, that the growth in big data, 600%. That's huge. So guys, if we discuss about the careers in Hadoop, the companies who are hiring or using Hadoop, almost all the companies today are using or hiring Hadoop. Companies are hunting for the Hadoop, guys, like anything. IT companies like Infosys, Accenture, IBM, TCS, Wipro, Cognizant, and so on. Analytics outsourcers, Mu Sigma, Fractal Analytics, Absolute Data, LatentView, Genpact. Retailers, Reliance, Walmart, Sears, Tesco, Carrefour. Consultants, PwC, KPMG, Deloitte, McKinsey, and so on. Companies, financial, domain-wise. If I talk domain-wise, so guys, we are having Citibank, SBI, HSBC, ICICI, JP Morgan. Telecom domain, Airtel, Reliance, Vodafone, Idea, TTSL. Healthcare domain, Novartis, Dr. Reddy's, Ranbaxy, Cipla. E-commerce, Amazon, PayPal, Flipkart. Guys, everybody is today using Hadoop. Everybody is using Hadoop. There is a huge demand of Hadoop in the market. Even if you type in the Google Trends also about Hadoop, you'll see exponential curve, not even linear with type. The curve is pretty much exponential. It's going very fastly, very high. So guys, that's it from my end. That's it about the introduction about Hadoop. So guys, if I summarize the things what we have already seen, we have seen the introduction to big data. Although it was not just the introduction, we had a deep dive into big data. Apart from that, we have seen 4 V's of big data. After that, we have seen conventional approaches and problems associated with the conventional approaches. So guys, after that we have seen what is the solution, that is Hadoop, introduction of Hadoop, Hadoop architecture, MapReduce and HDFS, that is the 2 components of Hadoop. We tried to understand their flow, we tried to understand their architecture via animations. After that we have seen use cases in great details. After that we have seen the Hadoop ecosystem. So guys, the forum is now open for all the questions. You can post your questions. I'm here to answer all your questions.
Hello, Vishal, you can ask your question now.
Okay.
Vishal, you can speak. You can ask your question.
Hello. Can you listen me?
Yeah, we can.
Yeah.
Please go ahead.
Yeah. Go ahead.
So actually, I want to say that what's the scope of the freshers in the Hadoop?
Okay. So actually, if I talk about till 2013, people were not accepting freshers. People were not accepting freshers for the Hadoop because it was pretty new till that time. But today the requirement has increased like anything. Today alone in US there is a requirement, there is a deficiency even I should say for the around 1.5 lakhs people for the big data. From mid of 2014 or start of 2014, people have started accepting, and I am also taking people, all these senior guys have started accepting freshers also. So guys, today everybody is accepting freshers if they are having prior knowledge of Hadoop and big data. And I would like to add one more point here. Guys, if a fresher is starting his career with big data, if fresher is starting their career with big data, it would be a golden opportunity, a golden chance for them. By the way guys, I am having few examples in my previous batches. The fresher who has attended the sessions, they are placed in companies like Morgan Stanley, companies like Mapr, companies like EMC and so on.
Hello everyone. So any questions you guys have, you can raise your hand and we'll unmute you and you can ask your question, because we have quite a few people here, so we are not able to unmute everyone at once. So whatever questions we have, let us please raise hand and we can just unmute you and you can ask your questions. Yes, Kishore Babu, you can ask your question now.
Yeah, I am from automation testing. What would be the future if I switch to Hadoop administration? Because I have basic knowledge in Java, so I am planning for, earlier I have Linux administration certification, and I am planning to do Hadoop administration. What would be the future?
Okay. By the way, you are having a very unique profile. You are in testing, and you have the knowledge of Java as well as Linux also. So you are having all 3 options open for you. So regarding coming to your question regarding the administration, so guys, today since the systems, since the architecture, since the clusters are getting deployed very fastly, today there is a requirement of admins even more than the developers. And the task for the admins are very challenging and very, it's like very if you like the challenge, if you want to enjoy, it won't be monotonous. Why? Because you are going to manage, you are going to maintain, you are going to monitor the complete cluster, a cluster of say for example 100 nodes. The opportunity in the market is very good. It's for the admin, even today I'm saying it's more than the developers. And since you are having the basic or some background of the Linux, surely you can go ahead for the admin course also. And even if you want, you can go ahead, since you are having the Java knowledge also, you are having the option open for the development also.
Okay.
I would like to just give another point with this. So if you are interested, I would say if you go for admin as well as developer, that will double your chance of getting the job. By the way, getting a job is very easy in Hadoop today because there is huge requirement. Almost everybody who's learning Hadoop, who is switching their career, they are getting the job quite easily. But since you are having a unique profile, I would recommend you, if you want, you can go ahead with the two streams parallelly. That's development plus admin.
And I have one more question. With the basic Java knowledge, can I go for Hadoop development?
Yes, just basic knowledge of even core Java is required, not even advanced Java, not J2E. Just basic knowledge of core Java is required for the Hadoop development.
Okay. Yep, thank you.
My pleasure to answer your question.
Yes, Manoj, please go ahead with your question. So Manoj has a question. Manoj, can you hear us? I think he has some problem with his microphone. So his question is basically, as a fresher, what is the percentage of getting a job? What percentage he expects to get a job as a fresher? I think similar to what Vishal was asking earlier.
Yeah, as I told you guys, for the freshers also the possibility of getting the job is very high. Say for example, you just be a little bit dedicated, just even I guarantee you, after attending this session, you can easily get the jobs. Just be dedicated, finish all my assignments. Even today, in today's industry, anybody can't really claim that after attending that you will become the master. But I'm saying just to finish all my assignments, just attend these sessions carefully, and you can easily get the job. That's not a big deal, guys. For the freshers or for the experienced, today guys are hunting like anything. If I give my own example, we just 4 months ago, when we had the requirement of around 12-13 guys, we got around 150 interviews. We have taken 150 interviews. We got even more than that resumes, and we selected only 4 guys, just 4 guys, because just 4 guys were having the knowledge. So you can imagine the requirement is very huge and the talent is very less currently in the industry.
And Vishal also has a question, and I think he would ask it. Yeah, Vishal, you can go ahead with your question.
Yeah, so I would like to tell that what level of project is required in the Hadoop. As in the Java itself, I developed 2 live projects, and in Hadoop, I feel it's a little bit difficult to develop a project or a live project because the hardware requirement specifications and all the schemas are in the Java. It's simply, I mean, want to say is in the Java we require just a runtime environment and a simple software, but in the Hadoop itself we require a lot of hardware. So what kind of project is required if we have to enter into the MNCs?
By the way, we are going to have a real life project during our session, during our course only. We are going to have 2 mini project as well as 1 real life project. Okay, the sentiment analysis, a very big project that I have shown you, that only we are going to have during our sessions, the very first thing. Secondly, let me clear your concept, guys. It's not like we need a very big hardware just for the learning and number of hardware. No, from a single machine, even during our sessions, we are going to use virtual machine, merely a virtual machine for all our practicals, for all our workshops, and you can develop your complete project with just one virtual machine, not even physical machine. Same as Java, since it works on single machine, it works on single JVM, Hadoop will be working parallelly. So when you will enter in the industry, at that time you will need clusters of machine. But for all your learning, for all your testing, for all your R&D, you can go ahead with just single machine. And the complexity of development is not really that much huge. You just need to understand the flow, guys. Frankly speaking, if you understand, there are a number of frameworks in Java, like struts. In the struts you need to code in a specific manner, in a specific way. In Hibernate you need to code in a specific way. In say Spring you need to code in a specific way. Similar to MapReduce, similar is the MapReduce, you need to code in a specific way. It's not that much like rocket science. If you understood the concepts of, let me even clearly tell you, there is some concept that's called key and value in Hadoop. If you understand that, you can master Hadoop easily. Guys, if I give you just the previous batch that ended just 4 days ago, my previous batch, there I had a guy who was having 20 years of experience. 20 years of experience, a guy who was the highest experienced guy. He, by the way, he joined from UK. And another guy that was merely a fresher, that is from the Vellore Institute of Technology. Guys, by the way, I usually during these sessions I provide another award from my side, that's Student of the Batch award. And the award that student won, that student that is fresher, that is even studying in 3rd year at VIT, that guy won that award. So it's just merely about the dedication, it's just merely about your attitude of learning. It's not that much tough.
Alright guys, so do we have any more questions that you want Rahul sir to answer? I think we are pretty much done with the questions and someone. Yeah. So I see a couple of questions around the certification part and all. So I think we will be giving you details on that, on the kind of certification that you will be provided and all. I think Preeti will get in touch with you. And the other thing, just to sum it up and conclude the session. One thing that we have to understand, I see a lot of people asking questions around, is it very difficult as a fresher to get a job? Is it very difficult for to develop a project or something? So the only thing that we have to understand here is that nothing is that difficult if we take the right approach, right? We were just talking about a few examples, the conventional approach and then the big data approach, right? The Hadoop approach, right? So if we do it in the right approach, things are easy. And as you could listen into the session itself, that Rahul sir talks about a lot of live scenarios and the used cases and all, that will make things more interesting for you. You will start finding interest in the subject matter and you will start understanding things right from the basics, right? So that will make you understand things and go ahead and crack the interviews as well. You know the subject, you can crack interviews easily, right? So it's all about the knowledge that is being shared and how much interest you find in that thing, how interesting the trainer is able to make. And I'm sure you were pretty much impressed by the session that we just had today. Okay, there is one good question that I see from Kishore Babu. He says, will you provide any hands-on real-time experience for Hadoop administration for freshers? So that is something that I think Rahul sir would answer. Sir, he's asking on the real-time hands-on experience.
Yeah, we are. Right. So Kishore, we are going to provide, say, firstly, let me take from the developer perspective also. We are going to provide you the real life examples, real life project of actual project, as well as 2 mini projects, firstly. Secondly, guys, more than 70%, more than even 75% of the course will be practical. Mostly we are going to deal with the workshops only. Now, say for example, if we are looking at a specific topic, a specific theory, after that we are going to see the practical about that. Now coming to your question regarding the Hadoop administration also, yes, we are going to see the live actual deployment, what actual production in the production, how exactly we deploy. Guys, so what are exactly the best practices, how to deploy. Even we are going to deploy a real cluster on the cloud. We will be creating a 3-node cluster or 4-node cluster on the cloud, and we'll see how to deploy. Even we are going to see that manually. We are not going to use any tools that will make you handicapped. We are going to do all the configurations by our own hand, and we are going to provide that particular things. What are exactly the best practices, guys? By the way, these best practices are still very tricky. Very less number of guys in the industry knows what or how exactly we should deploy clusters so that we can get the best performance from that cluster. By the way, this is expected from an admin, from an expert admin. The same thing we are going to see. I think
Right.
Amarjeet, you are muted.
Yeah. So I think that's most of it. I think most of them have got their questions answered. I don't see any more questions coming in. So that is it. I think Preeti, from our team is gonna get in touch with you, and she will discuss further with you in terms of when we are planning to start the batch and how you get enrolled for it. And I think that's it. Good to conclude at this point of time. Rahul sir, any final things that you want to add before we close the webinar?
Yeah, sure. So guys, firstly, I hope you guys have already done the market research about the big data. Big data, since it is developed, it is developed by the top-notch talent. Most of the code came from Yahoo, Facebook and all. It is a very, very demanding. So if you people are thinking that today big data is there, how long it will survive? Big data will be there in the market. According to Forbes, it will there in the market for next 45 to 50 years. So if you are thinking that tomorrow how long it will be there, it will be there forever. At least 45 to 50 years the production is there. Apart from that, regarding the jobs, guys, the pay scale in the Hadoop is very high. If I talk about, say, freshers like 0 to 1 years of experience in Java, if they are getting suppose 3 to 4, in Hadoop they are getting around 7 to 8. It's almost double. Even in my previous batch, I shouldn't share the name, the guy who attended this, he got placed in Morgan Stanley with a package of 13 lakhs. So guys, the future is very bright in Hadoop, and for specifically for the students and for even senior guys also, it's not that much difficult to learn, but it's a very new, innovative and different form of concepts. Alright, so guys, that's it from my end. Hope to see you in this session. Thank you so much for attending.
Alright, thank you all. Thank you guys for attending, and any queries you can just drop in an email to us. I think Preeti has shared her email ID with you. You all can drop in your queries, and Preeti will be again going to be your point of contact. Okay, thank you all. Have a good night. Thanks. Bye. Thank you, Rahul sir.